So today I'm talking about where we're going with Lustre in terms of some features, and James has already talked about compression is something that's already well underway, and will be coming in the upcoming ISC23 release. But everybody here is familiar with we've talked about AI, ChatGPT, large language models. There's a huge increase in demand in terms of capacity, IOPS, growing resolution. DKRZ was talking about more higher resolution models coming in, and that's just a huge growth in performance needs and capacity needs. And so lots of these things, you can grow systems with flash. Not everything can go, TLC flash to the largest scale. And so, we are working on, like was mentioned, compression. And also, we still maintain hard drive-based systems working well to provide, low cost per terabyte. And, having online storage is still more accessible than having tapes that are offline and need to be loaded. One of the nice things with EXAScaler is even with tiered storage, it's not like you have to load data into a faster tier to access it. It's always directly accessible. So you're getting, if your job definition script doesn't, list some file, your job doesn't fail. It's just pulling it in from the disk. And we are also working on improving availability and reducing complexity in storage. And one of the other important things that's coming up, it's ironic, in the first days of Lustre, we were working hard to aggregate enough storage to provide performance for these large systems. But as the compute nodes get large, we're actually having to subdivide a storage system, and provide isolation, data security, privacy for medical data and things like that. And so, we're having a lot of different needs, right? And this slide quickly, you can't see the systems. This is actually showing the large systems over the last 20 years or more since Lustre was first deployed. And the blue graph is performance improvements. The red is capacity improvements. And what's interesting is, as I had compiled these numbers a couple of years ago, that looking at the drive capacity, that we actually grow Lustre file systems faster than the capacity of individual drives, right? And so we're getting more drives, larger scalable units as capacity grows. And we actually have a similar statistic that we grew the performance of the file system faster than network's bandwidth because of optimizations that we're able to do in the code to improve performance. So we're growing faster than the performance of just the physical components. And so it's important to note that Lustre and EXAScaler have been around for many years, but there's still a lot of interesting development going on. We can scale basically as large as systems need it, and it's pretty much proven that EXAScaler is the solution of choice for AI systems. I mean, NVIDIA has deployed it on all of their large SuperPod systems, but we can also scale down on the low side, right? James was talking about the 2U server that can provide workgroup storage for a small small lab, but still provide very good performance. And Lustre in the top 500, the graph doesn't show on the top graph. It's systems in the top 10 and in the top 100. And Lustre as a whole is still dominating in this market. And on the bottom, we're still growing the bandwidth. And basically, your budget is the limit on the scalability, right? And we're happy to, help you explore, as far as you want to scale, right? And so we are continuing to do, lots of interesting developments. So, in this diagram, it's basically showing, all of the different kinds of configurations that we can have, right? And not every site is going to have every type of feature that Lustre can provide. But I mean, we can have, HDD OSTs with compression, soon, in the future, erasure coding, QLC OSTs, NVMe dedicated OSTs, archive to tape if you really need it, scaling clients, tens of thousands, up to hundreds of thousand clients. And, even one of the things with NVIDIA is they even manage on server, like their compute servers, the DGXs, the local NVMe cache storage is managed through Lustre so that you don't have to do data copying and manual management of your data sets, right? And so, a lot has been said about, where is I/O going in terms of interfaces, right? I mean, POSIX has been around a long time, right, since the 70s, and Lustre provides a very strong implementation of POSIX. And so, there's been lots of things said about, is POSIX, reaching the end of life? I mean, is it Fortran, is it tape, hard drives, are they reaching the end of life? But in fact, there's a lot of new interfaces being proposed, but everybody comes back to the fact that POSIX is providing the standard interface, for applications. And even though the standard is, of POSIX itself is not evolving so much, but Linux is providing really the de facto standard for every compute platform today. So if an interface exists in Linux, you can think that that's the proxy for what POSIX provides. And so we actually support a lot of new features in Linux. Asynchronous I/O can provide very good performance. IOU ring is actually providing asynchronous metadata operations in Linux, and we support that. And the other thing that's interesting in Lustre is that because we control both ends of the protocol, we can actually do lots of interesting changes to the internals of the file system that you can't do with NFS filers or anything like that, right? So we can do client-side data compression, right? And you can't do that in NFS, right? And so we can leverage the capacity of, compute cores on the clients to do data compression, and you get, a handful of clients, you have enough cores to saturate the storage bandwidth, but in fact, you can exceed the storage bandwidth, you can exceed the network bandwidth because you have so many cores that will compress faster than the storage can accept the data, and you double your bandwidth, you double your capacity. And so I think, in my opinion at least, that POSIX is going to continue to be the de facto, lingua franca for all storage systems, even, Red or I don't know the new name anymore, but Infinia is, providing a POSIX interface, right? It's going to provide its own lower level interface, but it's going to provide POSIX because that's what many applications still provide. So some of the newer features, beyond EXA63, these will be coming in EXA7. So metadata write-back cache, this is actually an internal client feature inside the Lustre client that is allowing metadata operations like file creates, directory creates, and things like that to happen only in memory on the client without doing any network transfers to the metadata server. And so this, in our testing has shown at least an order of magnitude improvement for certain workflows where you're extracting data. Let's say genomics is a common one where you have a bundle of small gene sequences that you untar at the beginning of your workload. you compute on those things, comparing the sequences against each other, and then you're done. And so, in fact, for workloads like that, metadata write-back cache can actually improve this performance significantly. And the nice thing about it is that this happens transparently to your application, and so you'll get a speed up if your workload does that, and it won't hurt your performance if you don't do it. And it still maintains consistency across the file system, because even though all of these files live in the memory of the client, because there's strong locking between the clients in Lustre, if any other client is accessing that directory tree, that part of the path gets flushed out to the servers, and then everybody is globally accessible. And so in some of the benchmarking we've done, comparing MD test, which is a common metadata workload, and we've seen almost 100 times improvement in this workload, this is separate directory per client. And so this is a perfect scaling case, I won't lie, but this is improving performance dramatically for the right workload. Another area that we're looking into is client container image. This is another mechanism for aggregating large amounts of small files together. So rather than storing every individual file as a separate entity on the metadata server, you're actually storing a file system image, and it's stored on the data servers. And so then you can pull in huge chunks in reads and writes from the OSTs the image file, and then the client processes the small files inside the image individually, and so you don't have a high load on your metadata server. And so we can again see in some benchmarking that we've done, and this is a little bit farther out into the future, but in our testing locally, we're creating a number of threads running on a single client, each one creating 12,000 files, and you can see the dark red bars are Lustre individually, and then we did run the container images where each client thread, this is a single client, but 1 through 16 threads writing into each one its own container. The orange was giving us a good improvement, but then in fact we found out that there was a bottleneck on the particular Linux kernel that we were running. And so the yellow bars are a newer Linux kernel, and we were actually, saw a much more significant improvement. And so up until the cache limit, at least, we can actually do aggregate data that's faster than, what the network can do, because we're, caching a large amount of data and then pushing it asynchronously out into the background. So just a quick summary of what's coming up in future versions. Questions?
Thank you very much, Andreas. Do you have any questions for Andreas at this time?
Thanks. So you mentioned the client container images.
Yeah.
Are those designed such that users can bring their own, or is it so that you say that, hey, I want to make an image now, and then...
It's originally, they can be any, strictly speaking, they can be any kind of image, right? File system, they have to be mountable by Linux, right? But typically it'll be like ext4, right, or something like that. In the initial versions, it's just going to be automation of, you'll essentially, set a label on the image file, and then when clients access it, it will auto-mount it, right? And so in the first version, it can be anything. In later versions, we might restrict it to ext4, because then the MDS will actually also be able to serve it out in a shared mode if you have shared client access.
But will EXAScaler ship the tools to manage these for users, or how will it work?
Yeah, that's once it's ready, yes, it will. All right.
Okay. Thank you very much.
Thank you.